Hi, welcome to this lesson on calculus optimization problems. Let's have a look at question 2. We want to determine the shortest vertical distance between the following curves f and g if it is given that f of x is negative x squared plus 2x plus 3, so that's this quadratic function f, and then g of x equals 8 over x for x greater than 0. So this is the restricted domain of a rectangular hyperbola, 8 over x. So it's only in this positive region, the first quadrant. Okay, so how do we find the shortest vertical distance? So what this just means is that if we have any 2 points, so any 2x points, we're looking at the vertical distance between these two functions. So we need some sort of function, an identifying function, that'll tell us what these distances are. Once we have that function for the distance, we can apply the optimization techniques by finding the first derivative, setting it equals to 0, and then solving for that x value. So how do I work out the distance? So I'm going to call this function d of x for distance. And I notice that the green function is always above the blue function. So therefore, to find that vertical positive distance, I'm going to say it's the green function g of x minus the blue function f of x. That will give me this height between those x values, the distance between them, the y value here minus the y value at here. Okay, that's g of x at that x point, and that's f of x at that x point. Okay, so what does this simplify down to? That's 8 over x minus negative x squared plus 2x plus 3. So I put brackets here because of that negative x squared, so that when I distribute out the negative sign, it becomes 8 over x plus x squared minus 2x minus 3. So that is my distance function. I need to find the shortest vertical distance. So that's a minimum point. So at point x there, when we find the derivative of the distance, so what's the derivative? So first of all, this 8 over x is an issue. I'm going to write it as 8 times 1 over x, because that gives you 8 over x. And 1 over x I can write as x to the power negative 1. So now it's all in exponential form. So I have 8 times x to the negative 1 plus x squared minus 2x minus 3. So derivative laws tells us that's going to be negative 8 times x to the negative 2 plus 2x minus 2. Okay, I don't like negative exponents, so I'm going to write that as negative 8 over x squared plus 2x minus 2. Because remember, the derivative of a constant is 0. Okay, so now we have the derivative of the distance function, and we want to set that first derivative equals to 0. So this x squared term here, I'm going to multiply on both sides. So I get negative 8 plus 2x cubed minus 2x squared equals 0. So I'll rewrite that as 2x cubed minus 2x squared minus 8 equals 0. Okay, I can further factorize that a bit. So I can pull out a 2. So that'll become x cubed minus x squared minus 4 equals 0. So remember, the goal is to solve for that variable x here. Then that'll give us the x coordinate, that'll give us the shortest vertical distance between those two functions. So how do I solve this? Well, if I divide both sides by 2, I get x cubed minus x squared minus 4 equals 0. This is a cubic expression, and you want to find equals to 0. So therefore, we need to use the factor remainder theorems. So the factors of negative 4 are plus minus 1, plus minus 2, and plus minus 4. So let's try x equals 1. We'll get 1 cubed minus 1 squared minus 4. That'll give you minus 4, which is not 0. What about negative 1? So negative 1, okay, negative 1, we're going to cube that. It's going to give us a negative 1 as well. Okay, so let me just try to get my pen back up here again. Okay. Almost there. There we go. Okay, so let's put that up here. So if I put negative 1, that's negative 1 cubed minus negative 1 squared minus 4. That's going to give you negative 1 minus 1 minus 4. That's still not 0. Okay, so now we carry on with the factors. What about 2? Well, 2 cubed is 8 minus 2 squared, so minus 4 minus 4. That's 0. So x equals 2 gave you 0. So therefore, x minus 2 is a factor. Okay. Now, to get an x cubed, I need an x squared term here. And to get a negative 4, I'm going to need a plus 2 here. So I just need a plus bx term here, and then I'm done. So I'm going to use logical inspection. The x squared term on the left-hand side is negative x squared. The x squared term is going to be x times bx is bx squared. Negative 2 times x squared is negative 2x squared. So if I bring over that negative 2x squared, I get bx squared equals 1x squared. So therefore b is equal to 1. So there I've factorized it. Okay, so now I've got x minus 2 times x squared plus x plus 2. Okay, I don't think that this can be further factorized. And let's actually check something. I'm going to look at the discriminant of this to see if there are any real values that when we try and factorize this thing. So the discriminant is b squared minus 4ac. Okay, so nature of roots test. So b is 1 here. So I get 1 squared minus 4, a is 1, and c is 2. So 1 minus 8 is negative 7, which is less than 0. So therefore, there are going to be no real values that when you try and solve, try to factorize that expression, that you will find it equals to 0. So therefore, this can't have any solutions, any real value solutions anyway, that'll give us 0. So therefore, the only real value solution to this is here, when x is equal to 2. So at x equals 2, what do you have on the green graph? Well, 2 and 8 divided by 2 is 4. And then on the blue graph, when you put in 2, what do you get? It's going to be negative 2 squared is 4. 2 times 2 is 4 plus 3. So that's going to give you 3. Okay, so the distance between 4 and 3 is just 1 unit here. So the shortest vertical distance between these two curves is 1 unit. Okay, and that'll be the shortest distance. So let's just recall the logic here. We needed a appropriate function that measured the distance between the two graphs. That was given by the y values of g minus the y values of f, which is g of x minus f of x. Once we simplified that algebraically, we ended up with this expression. We then followed the methodology for optimization. We set that first derivative equals to 0, and we got the following cubic expression. X cubed minus x squared minus 4 equals 0. So to solve this equals to 0, we needed to use the factor remainder theorems to fully factorize this cubic expression. Doing that, we had x minus 2 times x squared plus x plus 2. Okay, so having that being fully factorizable, okay, we looked at the quadratic expression and we saw that the discriminant here was negative, so therefore there weren't any real solutions. It wasn't going to cut the x-axis at all. Okay, and we could just, be 100% safe and check if we expand this out, do we get back the original expression? So I get x cubed plus x squared plus 2x, so that's expanding the first term, minus 2x squared minus 2x minus 4. Okay, so 2x and negative 2x cancel. Negative 2x squared plus x squared, that gives you negative x squared and then negative 4. So it does give us back that original cubic. So we did factorize this correctly. So the fact that the discriminant here, the nature of roots test told us that the discriminant is 0 or less than 0, then we can't have any real value solutions for solving that. Okay, so the shortest vertical distance is 1 unit between these two functions. I'll see you in the next one.